Hello guys, this is Mr. J. This is the video that we have been waiting for. This is exam number 1, exam review for chapters 26 and 27. Let's begin with chapter 26. Okay, first thing we're going to review is Pythagoras theorem. As you can see on the diagram, there is a right triangle. This is important to recognize that this only works with 90 right triangle. And here is that 90-degree sine. Okay, it says a square plus b square equals c square, where c is the hypotenuse, which is the longest side of this triangle, and it's always on the opposite side of that 90-degree. Here are some trigonometric ratios. We call it sine, cosine, and tangent. We will not deal with this for now. We will focus on sine, cosine, and tangent. Again, we have the right triangle and angle theta here. On the opposite of the theta is called opposite side. This side is called opposite. And as we just talked about, the longest side, which is on the opposite side of the 90, it's called hypotenuse. This is the longest side. And the side next to the angle theta, it's called adjacent, meaning next to it. So for sine theta, it is opposite over hypotenuse. For cosine theta, it's adjacent over hypotenuse. And you need to note that hypotenuse is always at the bottom on the denominator side for cosine and sine. And tangent, on the other hand, does not deal with hypotenuse. Tangent equals opposite over adjacent. So you must memorize these three in order to use sine, cosine, and tangent in chapter 26 and 27 as well. So let's do some practice questions. Okay, here is a diagram. This is from past papers. Also, question 21, this was shared with you as review worksheet slash, I don't know what you want to call it, but you have those packages with you. So let's take a look. So here is a right triangle. Again, this is important that it only works with 90-degree angle. So we have an option of using sine, cosine, and tangent. So here's angle theta, x. We're looking for angle x, and here's angle theta. And let's see what's given. On the opposite side, 3.4 is given. It's on the opposite of angle theta. So this is on the opposite side. And this is next to the angle theta. So this is adjacent. And hypotenuse is not given. So that eliminates sine and cosine, and we must use tangent. Tangent theta equals opposite over adjacent. So this means tangent x degree equals 3.4 over 4.7. And as we have studied, if we're looking for angle in your calculator, we must use inverse sine of tangent. Inverse sine of tangent. So on your calculator, you must press shift. And then tangent sine. And we would use parentheses. 3.4 divided by 4.7, close parentheses, and enter, and you will get an answer here in degree format. Okay, next question. Here is question number 4 from chapter 26. The diagram shows a cuboid, and it says work out the size of the angle between AH and the plane EFGH. Plane EFGH is the bottom plane right here. And AH is this in 3D shape, 3D dimension. So let's go ahead and draw what that looks like. So let's see if I can draw this correctly. It's hard to draw on this board, but let's see. So imagine that being a straight line, and it comes straight down. And also from F to H, we have this. And angle theta is this angle right here from the floor to the corner called A. So this also makes 90 degrees. Again, you need to be able to see this in 3D dimension. Hopefully by now you can see this. Okay, so in order to get that angle, I need to figure it out. So eventually we're going to use tangent theta. So step number 1, we need to, let's go backwards. In order to use theta, I need to know AF, which is given at 6. And if I know the length of FH, that is my adjacent side of that triangle. So I could use tangent theta. So step number 2, eventually we'll say tangent theta equals 6 over FH. So let's eventually, if I can know AFH, I can figure out angle theta, which is what we're trying to do. But step number 1 will be finding out FH. FH is also part of this triangle at the bottom. Use different color to show this. Okay, so that's this triangle on the floor. So if I were to redraw it, this F, E, H with 90 degrees. So let's put some dimensions in. This is 9. This is 5. And FH, let's call that X, is this. So we would use Pythagoras theorem, which is here. So we will say 5 squared plus 9 squared equals X squared, where X is square root of 5 squared plus 9 squared. So once you find X, now we got to put that X onto step number 2 right there. So once you put that in, you can figure out angle theta using shift or inverse tangent. Okay, let's talk about next sine rule and cosine rule. We already have spent 10 minutes, so let's see if we can finish this up. Okay, in triangle, you notice that this triangle is no longer a right triangle. This is not a right triangle. Versus sine, cosine, and tangent only works with right triangle. This is not a right triangle. Sine rule says the ratio between angle, the length of A, which is here, and sine A, here's angle A, the ratio equals the same ratio of B over sine B. So B over sine B. So basically the relationship between the ratio here, between A and sine A, is same ratio as B and sine B. And same thing goes with C right here. And cosine rule says A square, where's A square? So A square equals B square plus C square minus 2 times b times a times cosine a. Okay, we have done enough examples. I hope you know what that means. So, and also we will do some examples. So, and the last one is area of a triangle where it says half times a times b times sine c. Again, we will do some examples. Okay, so let's do this one. Okay, sine rule example. Okay, again, for sine rule, you need to have at least one known pair. Oh, my pen is not working. Okay, I'll take a pause for a second. Let's resume. Here is a sine rule example. And here's that known pair. So sine 80 over x equals sine 60 over 7. Now you can do cross product to figure out x. Let's do another example of cosine rule. Cosine rule says if I have two known length and an angle between, we can figure out the length on the opposite side of this angle. So the rule says opposite side square equals this square, 22 square, plus this squared, 28, minus 2 times this, which is 22 times 28 times cosine 97. Okay, eventually you will get rid of this square, and instead you will take the square root of this. If you punch this in your calculator, you will get an answer. Okay, area of a triangle. This is somewhat complicated, and we went over this today, and I'm running out of time. Got 6 minutes left to make this video less than 20 minutes long as required. I'm gonna move on. Chapter 27, mensuration. It talks about different shapes and volumes and surface areas. Excuse me. So let's begin with some basic concepts, which you should know by now. Areas for different shapes. Parallelogram. Area is given here. Okay, it's basically A times the height. That's it. This is exactly same as the any rectangle. Okay, rhombus, we're gonna skip this. We didn't learn this. Trapezoid is you add A and B plus A plus B first, and then multiply by the height, H, and then you divide it by 2. Okay, let's talk about circle, circumference, area, and sector. Here's a circle. Circumference is 2 pi r. Circumference is 2 pi r. And area is pi r square. Semicircle is half of that. Let's talk about sector. Okay, area of any sector, I call it pi for pizza, is related to the ratio of the angle. So angle theta here, which is here, over 360 gives you the ratio of how big or how the percentage of that small pizza slice compared to the whole pizza. So this ratio is important, and you simply multiply that to the area of the pizza, whole pizza, which is pi r square. Okay, all right. let's talk about this. Now 3D shape, volume, and surface areas. Let's begin with cuboid. Cuboid is, for volume, it's A times B, and then multiply by C. Okay? Cylinder. Well, let's talk about area. Total surface area. So it says 2AB because you have two of these on this side, on the other side. So that's why you have two. BC, AC. AC is on this side. AC is on this side. Again, you have two of those, so you have two. And BC is on the top. Again, you have this on the top and the bottom, and you have two of those. Two of those, if you add all six sides, you get area. Here is a cylinder. Okay, let's talk about this one. This is given to you, always given to you on O-level exam. If you understand this, great, but just in case you forget, they give you the formulas right here. Let's talk about cylinder first. Volume of a cylinder, again, volume is always the bottom area, we call it sectional area, times the height. So sectional area is 2 pi r, which is a circle, and you multiply by the height. Again, this is related to volume. If you put it on a sideway, this is a cross section. Okay, volume of any prism or cylinder is always a cross section times the length or the height, and that is related to here. Again, here we did the cross section, which is the bottom circle, multiply the length or the height here. Compared to this cylinder here, cone is exactly 1/3. For the volume of cone is exactly 1/3 of this guy. Again, this volume was this, and you simply multiply this by 1/3 to get the volume of cone. That's a special relationship. Okay, on top of that, there's a curved surface area given by 2 pi RH, and curved surface area for cone using this special slanted height of L. It's defined as pi RL. And volume of sphere is 4/3 times pi r cube. Pay attention to this cube, as volume is in 3 dimensions, and you get cube. Surface area of the sphere, surface area is 4 pi r square. 4 pi r square. Being area, you get square here. And the volume, you get cube. Okay, we're running out of time, so I don't have time to go over multiple questions. But let's do one. Okay. All right. Question number 3. Cylinder has the diameter of 14. Cylinder. Okay. I call cylinder Pringles box. Okay, has diameter of 14. So my radius must be 7. Okay, height of 20. Okay, pretty straightforward. Okay, work at the volume of cylinder. All right, let's figure out the bottom cross section, which is the circle. And circle has equation of pi r square. In this case, our radius is 7. So this times the height gives us the volume. So let's put in some numbers in. So pi and 7 square times height, which is 20, should give you the final answer here. Okay, that's the 20 minutes. I thank you for watching this. Hopefully someone will watch this. And more than this is, as you all know, this is not enough. And that's why I am doing review for you in the class. So hopefully you will have enough opportunity to study for chapter 26 and 27 and be successful on your exam number 1, which is on Sunday. So good luck, and I will see you soon.